Hello, I am Dhiraj Sahi. Welcome to this technical deep dive into binary exploitation. In this video, we will walk through the complete process of analyzing and exploiting a vulnerable Linux binary, a draft management service that contains a critical memory corruption flaw. By the end of this video, you will understand how to perform static and dynamic analysis of an ELF binary, how to identify signed unsigned integer conversion vulnerabilities, how to craft a cache positioning exploit, how to achieve remote code execution and spawn a shell. Let's get started. Before any dynamic analysis, we need to fingerprint the binary and understand what security mechanisms are in place. This tells us which exploitation techniques are viable. So let's get started. First, let's compute the cryptographic hashes to uniquely identify our binary. We use MD5 sum and SSA26 sum to create unique fingerprints. This ensures reproducibility. If we share these exploits, others can verify they are working with this exact same binary. So now let's verify whether these two hashes matches or not. For that, I used SSA 256 some cryptographic hashes to verify, and we can see in our course also same hashes is given, so it matches our coursework. Next the file. Next we can see that file cw1 command. The file command confirms the binary architecture, linking type and interpreter. We can see this is N64-bit ELF executable dynamically linked and not stripped. Now the critical part, the understanding the security mechanisms. Using point tools, check, we can see full railroad, no stack canary, and it's enabled no pi. This is important. No pi means the binary base address is predictable. No canary means stack based exploits are possible, but we will be targeting the heap instead. Using read ELF, we inspect the ELF header, the entry point, the machine architecture and type are confirmed over here. Next, the program headers. The program header shows us memory segments and their permissions. We can see the text segment is readable and executable, while data segments are readable and writable only. Next, we have section headers. There are altogether 35 section headers. Section headers locate important sections like .txt, .bss, .prd and .got. We will reference this later. The challenge also provides us a Docker file, and after inspecting Docker file, we can see over here it's also given how to use that Docker file. We can see the base image dependencies and how the service is exposed. Now let's load the binary into GDB, and without wasting any time, let's get started. After loading the binary in GDB, we can see GDB is given here. After that, we will run the program, and after running the program, it shows us that this is a thesis draft tracker version 1.0, and here are altogether 5 menu. In the first, you can see add new draft. In second, view existing draft. In third, delete draft. In fourth, edit draft, and in 5 we can see exit application. Now let's check the register. For checking register, I am using info functions. Info registers RDI, RSI and RDS. As you can see, here is the value of RDS is 31 right now, so we will figure out that later. So for this, I am running the program once again, and I am adding a new draft by clicking on choice 1, and after entering choice 1, I use my draft index as 0, and I use my allocation size as 32, and I typed for A. After that, it popped out how many lines or bytes to copy, so I pasted -1. After that, I used BT, and it shows me 4 thing, and after that I run the program once again, and I tried to edit part, but my draft wasn't saved, so I tried again and again, and I tried to create a draft once again, and I used that, and I used how many lines or bytes to copy. I used number 0, as number 0 copies all the things, and draft was created successfully. And after that, I used option for edit draft, and in edit draft I put my index 0, and after that I typed 4A once again, and when I do that, when I type 0, it again draft updated successfully, right? So let's go down, let's move. This wasn't working for me, and I used ./cw1 without loading GDB. After that, I created a new draft, and you can see over here draft is added successfully. And after that, I used delete draft, and I selected my index that was 0, and the draft was deleted successfully. Then once again I used option 1 to create a new draft or add a new draft, and after that I added my index, allocation size, and I used a lot of A's to whether see that 16-bit truncation works or not properly for this binary. And after that I used values in negative, and also it added successfully, right? You can see over here. After that I tried to verify whether the draft was saved or not by selecting option 2, and the draft was saved properly with the proper values I gave it. After that I used to add a new draft once again, but due to some error it gave me IoT instruction dot that one. After that I used GDB to load that binary once again. Then once again I run the binary, and after that I followed the same step and created a draft successfully with negative numbers. And after that I used to create a new draft once again, but it gave me a allocation size for that was corrupted top size due to malloc or something like that. After that I used BT to see functions, but previously it gave me only 3 functions, but now it gave me overall 9 functions. And then I tried to see what functions are vulnerable by typing info functions command, and it gave me a lot of functions, yeah, and I looked, I analyzed it, and I found 3 vulnerable functions, which I will show you later. So let's get down, let's move forward faster. What the heck, this is very stuck. Just wait a minute, guys. Oh, we can see a lot of functions are over here, and out of them I find some vulnerable functions which I am going to show you. Write down. And you can see over here mem copy cpy@plt, which may be vulnerable. We don't know anything yet. Then I put a breakpoint over draft copy plus 44 functions, and then after running the program, after creating a new draft and using a negative -1 sign, the breakpoint was successfully in draft copy at heap overflow. Then I tried to inspect the registers I showed you before, that is info registers RDI, RSA and RDI. Before there was written 31, but due to 16-bit truncation it changed to 65,535, and this is a very vulnerable part for any binary file. Then I tried to do BT again, and you can see only three functions are seen over here. After that I use set disassembly flavor Intel for Intel structure. Then I added breakpoint in this, and breakpoint 2 was successfully added in heap overflow 2.c, and I inspect how many breakpoints are created it, and you can see only 2 breakpoints, right? After that I use continue functions to continue, and after that I use BT, and we can see here only 3 functions are given, but now we can see total 4. After that I use p/d $edx functions and many more, and I inspected register once again, and it gave me mem cpy, and after that I did all the things that I could do. Then I found, then I inspected what's inside Gidra of this. Then I found that there was a lot of vulnerable part in this code. Also, you can see over here symbol tree, right? And after that, I inspected Gidra inside, and I found very vulnerable functions that copy from user input and edit draft, uh, which I am gonna show you. So let's get. After that, I knew that draft copy was vulnerable, so I inspected it. I disassembled it, every section of it, and also copy from user input. I found that this is vulnerable by inspecting from Gidra. So you can see over here what's inside here. And also edit draft function was that, right? So I used grep functions, grep command to see what's inside it and grep everything about it. So now I found this exploit which was very harmful for a binary file. So I created an exploit which ran successfully and give me a local shell and a remote shell, which I will show you after explaining this exploit. So without wasting any time, let's get started. You can see over here in the initial phase, it's about initial execution. The exploit script is launched and a connection to the target process, local or remote, is established via upon tools. Then after that, phase 1, we can see heap setup layout, right? A series of draft allocations are made to prime the heap into non-controllable arrangement of chunks. So I created heap section or heap layout over here. After that, I to find marker in heap and to find in libc leak. And to find leak in libc, we use also the functions leak libc, right? You can see over here a series of view or print primitive is used to leak a heap or libc pointer, which is used to defeat ASLR by calculating the base address of the loaded libc. So I wrote this code in order to resolve that. And finding a heap marker, a known marker value is located within the leaked heap data to reliably calculate offsets within allocated chunks. You can see over here. And placing gaps, we also place gaps. Additional allocation and freeze are used to place free chunks at control offsets, preparing the TCAS free list for corruption. Critical payload building, we also build critical payload by writing this kind of script. The malicious payload is assembled combining the calculated libc base with target addresses. For example, a hook or got entry to be returned via the overflow. And negative offset right. Right. The out of bounds write primitive is triggered using a negative length value, corrupting heap metadata located before the vulnerable buffer. So we write code for that also. And after that, let's go ahead in TCAS positioning TCAS. The corrupted TCAS release next pointer is manipulated so that a subsequent allocation returns an attacker's chosen address. After that, for triggering exploit, I wrote this code. The poisoned allocation is triggered and the attacker controlled data is returned into the target address, completing the corruption primitive. And after that, in final process, achieving the sale. Execution flow is redirect, resulting in a spawn cell, which I will show you right now. So without wasting any time, let's move. This is my exploit, and after running this exploit, we can see that we achieved sale. In our local device. Now I will also show you how to achieve a sale in remote. For this, I have written a different code which is very hard, which I created wasting my 3 days. And this code is over here. It was so difficult for me figuring out everything now. Let's move forward to for getting for getting remote shell we need to run docker file. For docker file I am running docker run cw1 latest, right? After that we will do wait, I will show you right now. What the heck, lost where? Oh, okay, wait. So this is the command to get remote shell. Should I show you or not? So let's get, oh, this is not working. Wait, just wait a while. What is this happening to my script? It's not working. Try until you die. Just wait, I will show you how to exploit this. Sometimes technical fault. Yeah, finally we achieved a share on remote environment, which you can see over here. After typing id, we can see id is user. Finally the exploit was done in a very good way, making it easy. So that was much for today. Take care.